Yes, we can.
All right, perfect. I'm sorry, my computer decided to die at the last minute here, but I'm on my phone and hopefully this will work out. Can we get this started? I guess the answer is yes. Hello, my name is Mohammed El-Batal. I'm a technologist at Seagate Technology, and part of the discussion today is going to be focused on NVMe HDDs. And as we presented earlier in the year, this is kind of a recap and some additional findings that we went through. Please go ahead, next slide. Quick legal disclaimer. So again, we're focused on NVMe HDDs for various reasons as the market pull has taken us there. From a Seagate perspective, we view this as an ask that's coming in with SATA replacement, as in the class of HDDs and cost point, and providing performance enhancements, obviously, and feature richness of the NVMe protocol. The simplification of the ecosystem is one, and then having a driver stack that's common with SSDs and a software stack that's reduced and not full of proprietary drivers, etc. So those are the basic asks, as well as NVMe over Fabric enablement as a streamlining, a more efficient transition from NVMe native or from the HDD native block layer to a fabric layer through some of the NVMe protocol capabilities like controller memory buffer, and some of the NIC acceleration that's available in some of the intelligent NICs out there that can actually take advantage of CMB and bypass the need for an additional memory repository for for the queues and the buffers of the NVMe over Fabric stack. The idea here is simplification and cost reduction of the NVMe over Fabric JBOD or FBOD in this case. Unifying data at rest and data in flight security with NVMe in light of the various secure server concepts that are being proposed, and trying to achieve that level of unification can only happen if all storage, in this case, all media types can converge on an NVMe protocol. It will make life simpler and more streamlined. Next slide. Other drivers for NVMe HDD come in from the overall technology evolutions. Starting with multi-actuator, dual actuator, and capabilities that require higher throughput, all the way to enclosure management and being part of a composable infrastructure that has an API that's composability ready, as well as standard delineation of QoS and timeouts and driver related issues with just the distinction of a spinning media instead of flash media. And going from there to acceleration potential of FPGAs and GPUs and CPUs, trying to get a direct hardware protocol connectivity to the storage would be simple if both SSDs and HDDs share the same interface and can take advantage of that in the case of data reduction or active drive or any concepts that will take advantage of the added features and modernized features of NVMe. Next slide. So internally within Seagate, we've done quite a bit of soul searching and looking at different connector types, etc. Within this subgroup, I think we're not, as Jason indicated, we're not trying to reinvent the wheel on various fronts. We're not going to create a new connector. We're trying to utilize existing defined SFF connectors, like an 8639 is a suggestion from Seagate, in order to allow for extendability of solutions that already exist. One of the concepts here is to use U.3 with 12 volt only. That's a suggestion again, where those are the areas we're going to discuss in subgroup meetings, etc. Next slide, please. So again, if we take into account the idea of utilizing a U.3 connector, it unifies the ability to start with SATA or SAS and then plug in an NVMe-HDD later in your design if you take into account certain things, like since it does support tri-mode in a U.3 wiring and capability from that aspect. So again, it's a proposal. It's not. It's something to be discussed. Next slide. So these are the specific pins that we absolutely need in an 8639 connection. But that said, one can omit a bunch of the connections within the copper connections on the SFF 8639 that are not absolutely necessary for HDD storage, because we're not going to go beyond 2 lanes as at least the thought process is right now. You don't need to go beyond that. So those are the suggested connections that would remain out of the second column of copper connections. Next slide. So at Seagate, we looked at signal integrity and the channel models of PCI versus SAS. Obviously, the SAS SerDes, maturities, and capabilities have enabled us for a long time to be able to do about 19 inches of trace or less at 10 to the minus 15 bit error rate, which was, it's necessary for a lot of different designs out there. As we go into a PCI environment, we looked at Gen 4 and we looked at Gen 3, and we feel like Gen 3 is more suitable for, at least keeping the same distance routing as SAS 3 and keeping the cost down on various aspects of the, the PCB layers and the ability to use connectors that are comparable to SAS 3. Again, we will push the spec through keeping it below 19 inches trace to get to 10 to the minus 15. We did this request from the switch vendors in the last presentation, beginning of the year. It's mainly focused around, well, do we really need full crossbar capability out of the switches? And could we create storage-specific PCIe switches that are mainly north-south focused in terms of throughput, and what things can the switch vendors, PCIe switch vendors, do to isolate a storage-specific solution for NVMe. Again, this is a recap of that request. The ask is, from the whole industry, is if we're going to go to NVMe, we really need cost parity and power parity between the switching components within a JBOD, whether they're expanders or PCIe switches. I'm just wondering if everybody's able to hear me, because I really apologize. Again, my computer died on me and I'm on my phone. I'm hearing some background noise, but I'm not sure if you guys can hear me.
No, we're hearing you, Mohammed.
All right, perfect. Thank you. Go to the next slide.
Seeing you.
Oh, good. Thank you. Again, there are specific nuances of the NVMe-HDD that on the hardware layer in terms of number of connections. Why would we need more than a single lane? It's because I think the vision is, if we can unify on a single type of a SKU of hardware that would enable by one or by two connections for future speeds and capabilities, as well as the concept of eventually being able to replace SAS solution even. And that would mean that we need the dual port capability. Now, in the OCP discussions, we could definitely start by discussing the by-one connection and the connector type and the PCIe nuances, signal integrity, and details around that. You can also look at clockless PCIe and whether everybody's ready to go there to SRAS, or can we just stick to ref clock initially and make sure things are working, and offer both. I think we've looked at that from an SSD perspective as a solution. We have that in our current silicon. SM bus support and VDM for out of band, as well as in-band, NVMe-MI. We'll talk about that later as well. There are some TBDs that the industry needs to really help us work out and guide us through. I think you can consider all of these TBDs, but these are suggestions right now. Next slide, please. So going to the key features within the NVMe standards, obviously, we've done the best we can to address those within the NVMe committee. Dave Allen from Seagate submitted NVMe TPAR 4088, and that was approved, and collectively with help from WD and others, it was passed, and we've worked through some of the concept for how would we support an NVMe-HDD in the same driver potentially, and not having to load a different driver when you put in NVMe-HD connection, simplifying as much as we can, and trying to bring existing tools within the protocol for using the capabilities of an HDD, and then tying things like CMB and SGL support, PRP, NVMe-MI, in-band and out-of-band to SM bus, ZNS support for potentially to use for SMR simplification in terms of virtualization of the SMR or providing better performance with SMR. Power management, spin up, and things like that could be addressed within that. At least that's the current proposal. Self-test, sanitize, telemetry. All these are features that we believe are needed and could be used on an HDD. Some things we're saying no to because we really don't see the relevance, but I think the subgroup is here to address all these things and decide on not only us. Next slide. Again, the spin up as proposed by the TPAR 4088 has had many discussions within the NVMe community committee group, and at this point, this is where they're at: is to have either basically at power on reset. If the spin up control is enabled, then we defer until initial spin up. Until we defer the spin up until initial controller process set feature command with power management that requests transition. And if the spin up control is disabled, then we begin initial spin up at NVMe subsystem reset. And after that, you can also, even if it's enabled, you can also toggle using the power management commands. So that's, I think that's the current proposal. I think this is dynamic at this point. We're still looking through, see what else we need to address here. Next slide. So the call to action, and as I mentioned, the TPAR is out there for the committee to work through the things within the NVMe committee. The OCP subgroup suggestions that we made are preliminary, and the subgroup feedback and suggestions are definitely welcome, and we'll follow whatever the standards dictates at the end of the day. You know, the NVMe HDD availability dates are being refined, but we're talking about late 22 to early 23 based on customer demand at this point, and it can change. And currently on the roadmap, we're showing it as 2025, on the early side of 2025 planned. And again, we repeat the ask for the switch vendors to work with us on replacing SAS3 expander, cost point, and PowerPoint. And then, you know, let us know if there's anything else that could drive NVMe HDDs in your environment, why and when, and bring it to the subgroup, please. And if we missed anything, please, you know, ask us to address in the subgroup discussions. And here's some links to questions and suggestions and mailing. I think that's the end of the presentation. Thank you very much.
Mohammed, there are a lot of questions on the FN virtual platform chat. Jason or one of, you know, I don't know who else is on the call here besides Jason, but David Landsman, do you guys want to take a look at those questions, or how do you want to handle that?
Yeah,
I can't
see them, so yeah, if you don't mind, I can't see them.
I've got them up in
circle.
Another window. Yeah, Jason, do you have them?
Dave, this is Ross. I can help you relay questions if you'd like.
Well, I mean, I've got them. So, can you hear me?
Yeah.
Yes, we can do that.
Yeah. So, do you want me to go through them?
Please.
Yeah. So, let's see. I'm trying to. Some of them came in before. Okay. So this, I think, is the first one. Maybe there was a question from Jun Chen. What is the projected power increase in NVMe HDD over a SAS SATA HDD?
At this point, I think the analysis that we've done is that the protocol itself is not the issue. It really is what we're trying to achieve in terms of throughput to the drive. So multi-actuator drives today, the dual actuator drive does demand more power as it moves more bits and more actuators are active. But the interface itself, as long as we stick to, you know, by one connection to by one connection, there's negligible delta in power levels.
I don't have anything to add to that. Jason, you want to? I don't know if okay, next question, or the next question I see is, how are you going to manage these switches like you can with SAS, with the SAS expander, i.e. SEP/SES for drive data?
Yeah, I think these are things that we need to discuss in the subgroup. At this point, from our thinking, is the use of common enclosure management BMC solutions. You know, one can view an internal capability with SEP and SES is you know, something we've enjoyed all this time, but we're not married to that, and you know, we're looking at it as an option, but you know, it was discussed as an option, you know, internally and externally. But again, the solutions are out there with BMCs that are pretty low cost, can be added and provide unification of you know, as well as provide more functionality. Like if it is an FBOD and you do want to streamline with control memory buffer, you could put the NVMe or Fabric target on that processor to kickstart things, and then once the enumeration is done and the completion of this initialization, then it becomes error handling and exception handling done with the small processor. So the thought is to think about it as a new solution that really is the difference between a SAS or a SATA JBOD and an FBOD in essence. But again, this is those are suggestions, but you know, up to subgroup to figure out.
David, any more questions?
Well, there's one more that just came in, but I'm also wondering, are there any people on the Zoom that, that had any questions in the Zoom audience? Maybe I'll take one from there and I'll go back to the list.
Yeah, I have a quick question on the interface. Are you expecting going to be like a combo interface, supporting both NVMe plus some other interface, SAS, etc., or you think it's going to be, going to be starting from the native NVMe-HDD interface?
Well, again, a lot of these discussions could be opened up in the subgroup, and I can just tell you about our internal plan at Seagate is we don't plan to have different silicon for different solutions. The silicon will have multiple interfaces, native initially, and but we plan to have a SKU that is optimized and designed for NVMe and with the termination needed for PCI, et cetera. And then another SKU would be for SATA and SAS. But ultimately, I think I don't see the pressing need for a trimodal target device. We haven't really thought about it, but it's a discussion to be had.
All right, thank you.
I think WD would concur with that too. We need to hear from customers and end users and see if there's anything that would change that basic view. And so hopefully we'll talk about that in further discussions. Let's see. Are we getting close? We got 2 minutes.
Yeah, exactly. And Shahar is on, so whenever we're ready, we can give him control.
Okay, there was the last comment that came in on the list was, can you comment on the call to action for PCIe switch component vendors? How far along are we in having vendor support for power and cost requirements? Mohammed, I don't know, maybe you've got an answer. I think that's all kind of, well, actually, I think we're going to hear from one, right?
Yeah, we're going to hear from Broadcom and Microchip in the subgroup as they join. I think let's not spoil the fun here.
Yeah. All right. Yeah, come join the conversations and to be continued.
Yeah, I was going to say join the project calls. You guys have a work stream. There's a mailing list set up. So I think that's the place to bring all of your questions, right?
Yeah, yep, agreed. And I apologize for my computer dying on me, but I'm glad it worked out.
It worked out just fine.